Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on Prosper software. And today's topic is about hydraulic jet pump. We will design the jet pump, we will install it to our well, and we will perform nodal analysis. Okay, so as usual, we start with this step. Okay, you can follow me. Fluid description, oil and water, method black oil, spirator, single stage spirator, no emulsion, disable PVT warning. Water viscosity, we will use default correlation. And for viscosity model, Newtonian fluid. For well, flow type tubing flow, well type producer. And this one is important. Artificial lift, open the drop-down menu, find jet pump. Okay, jet pump. And for the type, we will select annular injection, tubing production. Okay, so injection will be on the annulus, whereas the production will be through the tubing. Calculation type, offshore, rough approximation, full system, brine modeling default, well completion cased hole, no send control, single branch, and no gas conning. You can also type in the user information, the user comments as per your condition. Okay, so we can click done and we will wait. Okay, so now the PVT section is available. We can input our PVT data on the second tab. Okay, let's go in. Okay, so you can follow me for the input data solution GOR 800 standard cubic feet per stock tank barrel, oil gravity 37. Okay, 37. The gas gravity 0.76, water salinity 23,000 ppm, no H2S, no CO2, no nitrogen. For the bubble point pressure, solution GOR and oil formation volume factor, we will use Glasgow correlation. For oil viscosity correlation, we will use Beal et al. Correlation. Okay, if you have laboratory data, you can do matching, but we will skip this feature for the time being. Okay, you can input your lab data in this section and perform matching. Okay, I will skip it and press cancel. All right, so far so good. And this one, other data section, we need to input information about our power fluid. Okay, first viscosity, Newtonian fluid, emulsion, no emulsion. Okay, for the power fluid. Okay, power flow type, power fluid type, water with water salinity of 75,000 ppm. Okay, all right, click done. Okay, so we don't do PVT matching in this video. Now we go to IPR data section. I will select PI entry to make it more simpler. All right, to make it simple. Reservoir data, reservoir pressure 3500 psig, reservoir temperature 210, water cut 80%. Later on, we will do sensitivity analysis on the water cut, but we still need to input the water cut information here. Total GOR 800 SAF per STB automatically imputed by the Prosper because previously we input this information, this parameter on the PVT section. No compaction, no relative permeability modeling. Okay, so for this IPR model, we need to input PI only, and the productivity index is 6.5 stock tank barrel per day per PSI. Okay, we can click calculate. So you can see the AOF, the maximum flow rate is almost 16,000 stock tank barrel per day. Okay, you can click view results. All right, this one, these three columns. Okay, you can copy and paste on your spreadsheet. Click done, and you can click this one, plot results, to plot the pressure, temperature, and others. I want to show the pressure and temperature, for example. Click done. All right, so this is the IPR trend, whereas this one, the orange line, shows us the temperature. Most of the time, I don't need the temperature, and I will just only concentrating on this IPR plot. Okay, finish, done, done. All right, so we have our IPR. As usual, from IPR data section, we will go to equipment data section. We will input information about the deviation survey, downhole equipment, geothermal gradient, and for average capacities, we will use default numbers. All right, click edit, deviation survey. You can follow my data, measured depth, MD, and true vertical depth, or TVD, 00, 600, 600. Still vertical section, 1005, 1000. Starts to deviate. So we will create a deviated well here, 4075, 4000, 7700, 7500. And lastly, 9275 at 9000. You can click plot to show the configuration, measured depth against cumulative displacement. Finish, click done. Now we need to input the downhole equipment, starting from the Christmas tree. This is an offshore well. The measured depth 600 feet. Then we have tubing. Open the drop-down menu. The bottom of the first tubing is 1000, 4.052, default roughness, outside diameter 4.5, casing inside diameter 6.4. So from here, we can get the result for the annulus dimension, all right? The size, the dimension, or the volume of the annulus can be calculated automatically by the Prosper, all right? So yeah, you can see we provide the information on the casing inside diameter and the tubing outside diameter. And of course, we can calculate the annulus volume. After the tubing, we will have subsurface safety valve, triple S and V, with smaller inside diameter of 3.72. Again, we will have next tubing section down to 6,000 feet. I can copy everything here, Control C and Control V. Okay. Lastly, I will have my casing to the bottom of my well with the same casing inside diameter, 6.4. All right. And the same roughness. And for the rate multiplier, all one. Okay. There is no redirection of the flow. The flow will be on or will be inside the tubing, inside the safety valve, inside the tubing 100%. Okay. After this section, we will have geothermal gradient, overall heat transfer coefficient 8.6. All right, the depth reference at the rotary calibusing, and we will input measure depth here At zero depth, the temperature is 60 degrees Fahrenheit. At Christmas tree level, 600 feet, temperature is a bit cooler, 40 degrees Fahrenheit. And at reservoir depth, the temperature is of course 210. So far so good, click done. All right, now the equipment data section is completed. You can check again at summary. All right, equipment summary in a table. And you can also draw down hole by clicking this button. All right, so this is our well configuration, the Christmas tree, the tubing, the safety valve, tubing, and casing. Okay, so far so good. You can check also the MD, the measured depth, and the TVD, the true vertical depth. Click done, done, done. And we will wait for the well schematic. All right, so this is our well schematic. So from here, we will go to the design section and we will design hydraulic jet pump. Okay, let's go ahead. Click design, find jet pump. Okay, so you can see the window or the wizard for jet pump design is quite simple. All right, so you can follow me. Pump depth. All right, the pump setting depth, I will locate it at the bottom of my tubing, of course, at 6,000 feet with maximum OD of 6.4, maximum OD. Or we can also make it smaller than the casing ID because the casing ID is 6.4. But it's okay. We can make it maximum OD 6.4. And by design, I want to achieve 4,000 stock tank barrel per day. Water cut automatically imputed 80%. And also the total GOR automatically imputed 800 SCF per STB. Top note pressure 150. All right, top note pressure or the wellhead pressure. Surface injection rate for the power fluid 10,000 stock tank barrel per day with surface injection pressure of 2,000 psig. Quite high, that's why we call it power fluid. All right, the power from the fluid will be used by the pump and the power will be used and transferred to empower our production fluid to go from the bottom hole to the producer or to the surface. All right, that's why we call it artificial lift. Okay, nozzle loss coefficient 0.15, suction loss coefficient 0, throat loss coefficient 0.28. Okay, so the assumption of this video is you already understand about the basic of hydraulic jet pump design. Okay, so you can check again on the textbook or on the article regarding hydraulic jet pump design. And after you understand that, or even before you understand that, you can learn by this video. All right, using this video to understand the concept of jet pump design and also nodal analysis using jet pump. Okay, so we have nozzle loss, we have suction loss, we have loss at the throat, and also loss at the diffuser. And the coefficient is 0.1. Surface equipment correlation, don't need it actually, but just to make it better, I will change it to Bex and Brill. Or yeah, open the drop-down menu. It's stuck. Okay, never mind. All right, this one, Bex and Brill. And for the vertical lift correlation, petroleum experts. Second, petroleum experts too. All right, so from here, we can select the pump. or we can calculate the pump duty first. All right, very fast. You can see the pump duty. We get the wellhead pressure, flowing bottom hole pressure calculated, pump intake pressure, pump intake rate, right? Interesting. Free GOR entering pump and others, including average downhole rate of 4,664 and others. You can check, you can do it again on your Prosper and you will get these results. Very, very interesting. And you can also get the results here, the wellhead pressure, bottom hole pressure, flowing bottom hole pressure, pump intake pressure, PIP, pump intake rate, pump discharge rate, and others. And we can select the pump. Okay. You can check the catalog and you will find we have many types of pump. And among these pumps, I want to select test, nozzle 1, throat 1, this one, AN 0.004 at 0.009 or 0.410, and you will get the actual. Okay, so previously we only have the desirable, and now by selecting this pump, we will get the actual. So now the pump intake rate stays the same, 4,831, and the discharge rate now a bit higher, 15,100. And average downhole rate, this one, 4,831. Okay, so we have completed the jet pump design input section. We have done the design of hydraulic jet pump. We can click done. All right, and now you can see first, now we have our jet pump depicted here. Interesting. And the result from the design section will be automatically transferred to this section. Open this one. Jet pump input data automatically imputed from design section to this section. Okay, so now you can check, but you still can modify some numbers, but we will keep it. We have the pump depth at 6,000 feet. Okay, no need to change it. Maximum OD 6.4. Surface injection rate 10,000 stock tank barrel per day for the power fluid. Surface injection pressure 2,000 psig with coefficients for nozzle loss, suction loss, throat loss, diffuser loss, and current jet pump selected. All right, so far so good. Okay, after completing this section, now we are ready to perform nodal analysis. All right, we go to calculation, system IPR and VLP. Okay, top node pressure, again, the wellhead pressure is 150 psig, water cut and total GOR of 80 and 800 respectively. Surface equipment correlation, Bex and Brill, vertical lift correlation, petroleum experts too, like the one I selected on the previous section. Rate method, I prefer automatic geometric so that I can capture the zone at which there is a chance of unstable production. Okay, and this one disallow, no, this one. Okay, now I can create the nodal analysis by calculating this button, show calculating data. All right, so invalid fluid pressure. Okay, there's a problem. It's okay, click done. All right, now I want to create some cases. First, the water cut. I will create from generate. Okay, from zero water cut to 90. All right. And number 10. I want to create with linear spacing, generate. So I will have 0 through 90, 10 numbers. All right. And I want to vary also the jet pump injection pressure. This one, I want to vary it from 500, or I want to check it, generate 500 through 2500 with step. Okay, with step, I need to input first value. The increment will be 500. The number will be 5. Generate, so I will get this one, 500, 1000, 1500, 2000, 2500. All right, click done. So I have, you can see 50 cases. Let's check it out. Calculate, show calculating data. All right, interesting, right? So this is the thing that you will do. Okay, we have some errors, no problem. Invalid fluid pressure. It's okay, click done. We still have several cases that are okay. Okay, like this one, you can see we can still flow, or we can flow with production rate, liquid rate, this one, 8,796. With zero water cut, we will get the same for oil rate. So this one, the production rate decreases, with jet pump injection rate increases. You can see the trend, right? Interesting. From here, we can click plot, system plot, plot all cases. I want to show the VLP and IPR for all cases. All right. So I can get this nodal analysis. Interesting, right? So of course you can check, you can do this technical analysis, and you will compare it with the actual condition on the field. Can you achieve that injection pressure? What is the actual water cut? And then you select the best case that is relevant to your condition. Okay, but I will just show you many things that we can do using this software. Okay, so we can create 50 cases very, very, very quick. All right, and we will get very quick results. Finish. All right, you can also check them manually like this one. Okay, but lastly, I want to show you this sensitivity plot. You can see this one I created by plotting pressure against water cut. But the thing that I'm really interested into is variables. Of course, not pressure, although pressure is also important. But the most important thing, the thing I am really interested into is, of course, oil rate. Y-axis oil rate, X-axis variable water cut. And now I will have several or 5 lines of jet pump injection rate. Click done. All right, so you can see, of course, by having increased water cut, first oil rate will decrease. Okay, that is easily understandable. If you get higher water cut, you will get more oil and your oil rate will decrease. And another important observation is this one. We have the curves, curve 1 to curve 5, curve 1 injection rate low, 500, curve 5 injection rate 2500, but you can see if you increase the injection rate, you actually will get lower production rate in terms of oil in this case. You will get lower oil rate. But to make it clearer, we can also plot it like this way. Okay, so this is what you will get if you plot oil rate versus jet pump injection rate. So by looking at the graphs, it's quite easy to understand. If you have higher injection rate, all right, you will get lower oil rate. Again, if you increase the jet pump injection rate, you will get lower oil flow rate, all right, for each water cut, of course. All right, so yeah, we get that already. So now we understand that if we increase the injection rate of the hydraulic jet pump, all right, the injection rate of the power fluid, we in general will get lower oil production rate. So by looking at this result, we can, yeah, we can plan the injection rate, all right, along with the planning of our hydraulic jet pump sizing. All right, so I think that's all. I hope you enjoyed the video. I hope the video is useful. Thank you so much for watching and see you again in the next Prosper videos. Thank you.